Here we're looking at some elements. So written across the top you see aluminum, copper, iron, magnesium, tin, and zinc. You can see SN, tin. Across the left we have copper chloride, iron nitrate, and silver nitrate. And these are going to be added to the elements. And what we're looking to see, are these metals more reactive than the metals that are in the compounds? So you see these aqueous signs, you see them all the time in equations, and just what that means is that it's dissolved in water. So this is some copper chloride, and I'm going to go ahead and add this to all of them. Some of the reactions are fast, some of them are slow, so we'll see what we see. I just put copper chloride on top of copper. Okay, so the zinc, you can see the color changed very, very quickly. You can see the magnesium is bubbling. The zoom is not great. And it'll just stay there. Maybe you can zoom in. All right, so here's the iron, right? Aqueous, right? We see through it. And I'll just add this to aluminum, copper. The iron in this column, it's really small particles. Okay, so there's iron everywhere. And last is the silver nitrate. You can see just pretty much looks like water. Magnesium's reacting pretty fast. Tin as well. So one thing, you can see there is some reaction started with the copper and aluminum. So there's one thing with that, is that if you had copper sulfate instead of copper chloride, this reaction would not take place. So I'm going to go ahead and add sodium chloride to these. So shouldn't, right? The sodium's not reactive with this. Just want to make sure that, oh crud. Dang nabbit. Alright, so I added chloride, and silver chloride is not soluble. So I'm going to redo that one. Forgot about that. Alright, so I added chloride. Iron chloride is soluble, but silver chloride is not. So we actually put a double displacement reaction right in the middle of trying to look at some single displacement reaction. So I'm redoing the silver and aluminum. So I don't know if the aluminum is going to react. Okay, so I'll let this go a little bit just so you can see any reactions that might take time. Nice thing about recording reactions is you can tell exactly how long it took. copper is coating the surface. It's a little hard to see. So there's this, it's really a fine copper. But you can see that if I push it down under the surface, we can see underneath there's definitely a reaction taking place. As I stir it, the copper underneath what was reacting gets exposed, and now it can react. I'm just trying to pat down the, it's kind of this, it's almost a dust. It's so fine. I'm trying to get it underneath the water surface. All right. I'm not seeing anything here. Copper looks like it's just sitting at the bottom of the iron nitrate. I didn't mean to mix in the iron nitrate. I'm not seeing, something looks like it might be going on with this copper. Copper does form more than one oxidation state, so maybe we'll get something, but usually you just ignore these, right? Copper and copper chloride, we're not trying to see which one's more reactive. All right, clearly the aluminum is reacting, so that would tell us that the aluminum is more reactive than copper. I see some bubbles, so it might be hard for you to see. I just moved the bubbles out of the way. Anyway, there's bubbles forming, so we're forming a gas. So aluminum looks like it's going to be more reactive than iron. We can just give that a little more time before I shut this off. And then down here, dang it, I rinsed it with a little, just a littlest bit of tap water, and I precipitated some more stuff. So I'm not really seeing any reaction take place with the silver and aluminum. So we expect it to. We expect the aluminum to be more reactive than silver, so we expect something, but I'm not really seeing it. Maybe it takes a long time. Maybe it has something to do with the coating on the aluminum. All right, the copper is definitely more reactive than silver. We could see that. Copper looks like it's less reactive than iron because we don't see anything happening there. The iron looks like we see something going on in here. So that would tell us that, and you can see the water, the solution here is clear, right? So the copper ions have come out of solution, so you can see that. So the iron must be more reactive than the copper. Iron and iron, no real need to compare. And then down here, iron and silver. So yeah, it looks like iron is more reactive than silver. You definitely see something change there. Magnesium and copper. All right, you see some bubbling going on, and it looks other things. So something definitely happened there. And now we have magnesium reacting with it's bubbling. It's reacting with the iron, and same thing with silver. Okay. So all we're looking for is, hey, did a reaction take place? The zinc, we have a piece of zinc. It's definitely reacting with the copper. That would tell us that the zinc is more reactive than iron. Hey. All right, so got a lot of reactions going on. And tin. Tin reacts with copper, I would say. Oh no, yeah, that solution is definitely, it has lost its blue, so that is reacting. Tin's reacting with the silver for sure. And as far as the iron, I don't really see anything. I'll try to get a close-up, and then I'm going to turn this off. 10 minutes, that's way too long. That's it, first column. Third column. So that iron column, magnesium column. This is tin. To tin, and then there's your zinc. Bye-bye.